Section 6. Research activities. Let's start with looking into the international research activities. In this video, you can see a popular application where, when we are saying the research in industrial robotics, we are rather looking into the definition by the International Federation of Robotics, because as you can see, this is not a serial articulated manipulator, but the application that it is fulfilling is an industrial one. And here we can find the robot dog from Boston Dynamics working on a SLAM task, which is synchronous localization and mapping of factory facilities of Ford. Then, in the more conventional sense of industrial manipulators, looking into dual arm robots, we find human-robot collaboration to be one of the main drivers. And as aforementioned, the technological trends of simplification, collaboration, and digitalization can be expected to promote the installation of industrial robots because the programming and installation of robots becomes easier. Human-robot collaboration gives the ability to work in tandem with humans, and industrial robots are a central component of digital and network production as used in Industry 4.0 or the concept of cyber-physical systems. Here we can find another SLAM application where a quadrocopter is used in order to localize and map the facilities. This is also a project at the Ford facilities. And here we have an example of the Wandelbots, where they are going to exemplify the trace pan, which they intend to be used for an easier programming of industrial manipulators. One consideration when it comes to this video. I'm not 100% certain how this application works, but based on my understanding, I assume that while this seems to be a rather straightforward way on how to program industrial manipulators, you are actually then once again dependent on the accuracy of the industrial manipulator rather than its repeatability, which means that you probably will have to employ a calibrated industrial manipulator. And then we have a few examples of research that is being conducted within the department. And one of the biggest projects that we had in industrial robotics over the last years, and which had been concluded in October 2018, was the Coroma project, in which the intention was to make cognitively enhanced robotic systems for the manufacturing of metal and composite parts. And the idea was to develop several modules which could be combined in order to give an industrial manipulator more capability on the shop floor by being able to autonomously navigate the shop floor and then take over tasks such as inspection tasks, as well as actual machining tasks. In this project, we were collaborators to the Coro optimization module, which intends to measure the stiffness of the industrial manipulator to then create a more accurate robot model and to compensate for the anticipated deflections during manufacturing. If you have questions concerning that or similar projects, please feel free to contact me or Monica Gonzalez. Then, we are also having other research work being done at the department, for example here displayed by our colleague Xixiao when it comes to multimodal control of industrial robotic systems for human-robot collaboration. Here you can see how our colleague is giving voice commands to the robot to move. And here you can see how he is using a combination of the lead motion sensor on the table as well as lead through programming in order to fulfill the application. This brings us to the end of today's presentation. Thank you for your attention. So, just to quickly wrap up, today's lectures gives us the ability to understand, assess and justify the opportunities and limitations of industrial robots as potential solutions to challenges in manufacturing processes and environments by 1. Understanding the requirements and similarities between established application fields of industrial robotics in manufacturing processes. 2. Describing the configurations and working principles of industrial robots. 3. Assessing and justifying how different designs of industrial manipulators influence their performance. And 4. Identifying and preventing risks associated with the operation of industrial manipulators and robotic cells. I hope that you enjoyed this presentation, and I'm looking forward to your questions during the question and answer session. Please don't forget to submit the questions prior to the Q&A session so that we can choose the ones which were most difficult to the most of you. Thank you very much.